So hello and welcome back everyone after the minors, which were very hard, unlike the topic of today's presentation, which is soft matter and its applications in chemical engineering. So let's have a look at what is soft matter first. Alright, so all materials can be classified based on three length scales. Microscopic, which corresponds to interatomic or intermolecular distances, mesoscopic, which is usually around 100 to 1000 nanometers, and then macroscopic, which is anything larger than that. The picture you can see here is actually mesostructures formed by self-organization of metallic nanowires. And you can see the length scale, it actually matches that of mesostructures. So now while quantum mechanics must be used to describe microstructures, classical mechanics is sufficient for mesostructures and macrostructures. However, in mesostructures, thermal fluctuations must be considered. Also, soft materials are actually mesostructures, and so they can be broken down by thermal fluctuations. Further, there are four broad categories of soft matter: amphiphiles, liquid crystals, polymers, and colloids, and we're going to discuss polymers and colloids, having already discussed amphiphiles and liquid crystals in our previous videos. Alright, so polymers are actually very large molecules, large enough that their properties are actually governed by their size rather than their chemistry, which usually contributes to lesser important secondary properties. They are made out of multiple repeat units, and after around 600 repeat units, the polymer chain starts to show a lot of entanglement, as can be seen in this figure, which lends polymers their high strength. This, along with their resistance to corrosion, degradation, chemical inertness, and lightweight, makes them highly attractive functional materials. Okay, so let's have a look at their uses. Since the 1930s, polymers entered a golden age during which new types were discovered and quickly given commercial applications, replacing naturally sourced materials. Since 1953, 6 Nobel Prizes were awarded in the area of polymer science, further, testifying their impact on modern science and technology. Right, so they are used in paints, glues, anti-fouling coatings for chemical reactors or heat exchangers. They're used as transistors or diodes in electronic equipment. They're used in household items, buckets, kitchenware, etc. They're used in clothing, sportswear. They even have medical applications. They used as syringes, rubber gloves, contact lenses. They even used as synthetic membranes, fuel cell membranes, ion exchange resins in the chemical industry as part of separation technologies, etc. So recently, natural polymers like arginine, trypsin, polysaccharides have been used for drug delivery systems, and advances have been made in synthetic polymers like some polyamides, polyanilamines, etc., to make them bioreducible, biodegradable, and bioabsorbable, thus making them viable options for drug delivery, gene delivery, etc. Now, a very interesting product which was recently launched in 2020 was something called Thick Water, made by the company Thicket. Now, this is water made for people who have trouble swallowing, and it's made by adding xanthan gum to water, which increases its viscosity. To see such total integration of polymers from our clothes to the very water that we drink is really fascinating, I think. So let's come to colloids now. So they consist of two phases, a dispersed phase and a continuous phase. Now what is meant by this is, say if I have the dispersed phase as these particles and this is the continuous phase, then if I take one point in the continuous phase, then it's always possible to move from point 1 to point 2 while always staying in the continuous phase. So also the dispersed phase is affected by Brownian motion. Also, the size range of the dispersed is 1 nanometer to 1000 nanometers, which we can again see is the mesoscopic length scale. Now, colloids, they used in food thickeners as toothpaste, lotions, lubricants, ketchup, etc. They used in food products like milk, eggs, ice cream, which is a complex mixture of three colloidal types: emulsion of butterfat, foam of air bubbles, and a gel of ice crystals. Again, they're used in artificial rain, smoke precipitation, etc. Recently, colloidal-based nanoparticles were used in the fabrication of colloidal crystal arrays, holospheres, superhydrophobic surfaces, filler carriers, and smart nanomaterials. Okay, finally, there are many more types of soft matter with a vast variety of uses in the chemical, biomedical, materials industry. Okay, and they are highly relevant in today's society and have been totally integrated in our day-to-day lives. Finally, I'd like to thank Professor Shalini Gupta for giving me the opportunity to do this presentation on such a relevant and exciting topic, and also my parents for their everlasting support. Thanks.